My name's Chris from Immerse2Learn. What I'm going to discuss with you today is our Total Machinist training platform. We have been in business since 1999, debt-free, profitable, growing. What we focus on is development and distribution of an online training system for manufacturing and technology applications. Today we have well over 600 schools in North America, high schools, colleges that use our system on a daily basis, and we've been growing at a good pace. This would just be a sample list of some of those schools. All of them are very astute in machining and technology. Some of our key partners would be Haas, the H-Tech, NIMS, Mastercam, Fanuc, Renishaw, and Verisurf. And what we focus on is training for the product life cycle. So that would be concept, reverse engineering, CAD, Solidworks, CAM would be Mastercam, and the machining would be predominantly Haas, Fanuc, and then manual machining. And then we also cover inspection using Verisurf system and hardware and the Renishaw probe on the machine. So our courses are aligned to industry skill standards. We are a NIMS partner for covering CAD, CAM, CNC inspection, manual machining, core skills. And we also have curriculum for mold making, die making, and high-speed machining. If you were to look at our training packages, we have online learning packages from 6 months to 12 months. We cover 24-month packages. Learn CNC, the 6-month package, would focus predominantly on CNC and core skills. Total Machinist would also include things like probing, setting up multi-axis machines, all of the manual milling. And Total Machinist Plus then would include Mastercam, lathe, 2D, and soon 3D mill. All of this comes with the NIMS practice tests. So you can have your students go through those tests over and over again if you want them to take the NIMS tests in preparation. Or they could just take those tests without even doing NIMS just to confirm where they are with the national standard. For those that are familiar with Immersive, they would know about our virtual emulator. So every student that has access to our learning environment also has access to the virtual CNC control panels for mill and lathe. So it's accurate machine motion. You get the material removal of the parts. It's actually run by M&G code programming. So they can edit and save and write programs. There's a library of mills and lathes. Here's the TL1 with the newer control. In this, they can set their work and tool offsets. They can load a program and save a program. We have a plotter. So what this allows our customers to do, in addition to hundreds of hours of learning and testing and assessment, they can also utilize this capability at home, in the classroom, or in the lab, or at work to interact with virtual machines and controls. So the unlimited access to train and rehearse in a virtual environment enables the students to develop greater confidence and proficiency prior to using the actual equipment. They can overcome barriers of student to equipment ratio, increase training contact time even at home, minimize damaging equipment. In addition to the emulator, the curriculum is full of interactive exercises that are introduced to the students after they've learned a particular segment. They're designed in a game-like fashion where they have to beat the clock, or they can get 3 strikes if they get 3 wrong answers. It's not punitive, so it's not going into their final grade, so they can start over and keep doing this until they become more proficient at the task they're trying to learn. Here's just a few other examples of interacting with virtual calipers, and then various types of interactive math exercises. So everything that we do kind of stems around project-based learning, and it's all aligned to NIMS standards. For example, this is bluing of a part to scribe all your lines in the part. Some instructors still do it today, some don't. But what we do is we walk the learner through an entire project from beginning to end, so they have a very deep depth of knowledge in anything that we're teaching them. Here's the same example, but with tapping. This is getting into different types of metals. And then, for example, we also have all of our manual machining curriculum. So it's a very broad overview, and then it will get into an actual print, and then taking the student all the way from the beginning to the end. And what's really nice about this approach is that it allows the student to review a lot of material at home so that they can really spend more time working with the instructor to do the hands-on. It's as close as you can get to virtual because it's walking them through step by step by step on the machine. This would be a grinding example. So we have lathe, mill, drill press, and grinding. This is an example of a CNC project-based learning. They start out a little simple, and then they'll start to get more complex. In this particular project-based learning, the part has a round base, so the student's required to learn about making other just critical decisions like machining soft jaws, and then having to flip the part because there's other features on the back of the part. All of this particular project is done with M&G code programming. They will actually have to read the prints, select the tooling based on the prints, calculate the feeds and speeds, write the program, set up the operations, and then actually do the inspection of the part once it's complete. Here's a similar project-based learning for our lathe parts for CNC. And then we have, for CNC, very in-depth exercises in addition to the project-based learning, all of the interactive exercises. There's actually a booklet for doing exercises, tests, and then final programming tests. We have training for how to use the Renishaw probe and tool setter on the machines. And then what's nice is that when we introduce Mastercam, we take some of the harder M&G code projects and we incorporate those into some of the Mastercam projects so that students can see the one-to-one transition between M&G code programming and automated CAM programming. What else is nice about this is that each one of the individual projects actually is a part of an assembly. So that also enables the student to learn more about tolerance, stack up, and the challenges that go along with assemblies. And this would be the Mastercam project, which is it's based upon the M&G code project that the students would have learned in earlier CNC programming lessons. Same thing with the lathe. In addition to Mastercam, we also have the Solidworks CSWA preparation, plus the professional is also included in this. This is a very comprehensive, in-depth curriculum for Solidworks. It has all the quizzes, assessments, final exams, and additional challenge projects to get them ready for the CSWA. And then a very strong partner of ours would also include Verisurf. We formed a partnership with Verisurf years ago because we realized it was an ideal turnkey solution in industry as well as education for delivering not only reverse engineering of geometry, but even more importantly, inspection. And they offer, in addition to their powerful software that interfaces to hundreds of different hardware measurement devices, they offer turnkey solutions with, for example, the HP gauge, the Master 3D gauge, and then there's the Renishaw Equator, which is essentially a CMM application. With the Master 3D gauge and the Renishaw Equator, if you are doing NIMS parts, the tolerance on those particular devices can achieve what you're looking for your NIMS parts. And in addition, with Verisurf, is that they also have the NIMS optional package, so that if you are doing NIMS parts, you can inspect the NIMS level 1 mill part in 5 minutes and the lathe part in 2.5 minutes. And it has all of the programs already included in it. It has all the reporting done. So it's really an elegant turnkey solution for measuring NIMS parts if that's something you're doing or considering doing. That I mentioned earlier, the CNC 200 milling and drilling these are all industrial-based training applications that were produced in an actual mold and die shop. So it covers a lot of processes and machines that you would see in the industry. So we have the milling and drilling high speed, we have stamping dies, and then molds 100 plastic injection molds. So all of this content is built on a learning platform. So everything can be delivered turnkey and seamless to the end user. The content is aligned to the national standards. What's nice about the platform is the material is consistent, organized, and reliable delivery on a daily basis of instruction. It's modular, so you don't have to eat the elephant in one big bite. It's a bite at a time. The modules are usually 30 minutes to 40 minutes. So it supports flexibility in how you like to teach. Allows you to teach more efficiently to maximize the hands-on learning. And everything that we deliver is based on skills learning objectives, so that you can have measurable results that are aligned to the assessment testing already in the system that is aligned to the reports. So there are pre and post quizzes. There's inline quizzes. So if it's a long module, we might slip another quiz in there to break it up. And then there's comprehensive exams, which are exams that are basically all of the lessons in the modules in a course would be an exam. And these are examples of the questions, the answers, and the feedback. Once the students take a pre-test, a post-test, or an exam, that then goes in their assessment portfolio, which is what you see in front of you here. So it shows you the date, the time, the score, and it shows the improvement or not improvement from the pre-test to the post-test. And then it also shows the final exams. All of this can be output through CSV files so that you can use it interchangeably in other systems. A lot of success stories. We have customers that date back 13 years ago that use the system. They've grown their classes from a few students to hundreds of students. Pickens in South Carolina is an example of that. We have Desert View High School would be a great example where they're teaching hundreds of students. They transformed their shop from manual machining to a state-of-the-art training facility for high school students. You can see in 2016-17, they had 233 students go through our system. Which it was interesting, 184 boys and 49 girls. Suncoast is a community college down in Florida. They use this for all their students in NIMS preparation. So what's nice about our system is you can train, assess, and you can teach to national certification standards. I'm gonna pause for a second. I'll answer a few questions, and then what I'd like to do is I'll just go into the system and give you a quick overview of what I was just presenting to you. Are there any particular questions at this time? Is everyone still there?
Oh yeah.
Yeah, on the taking the exam, this is Frank.
Yeah.
For the students, I think you currently have it set at like 80% will get them a passing certificate. Is that correct? And is that modifiable? Does it have to be 80% or?
The standard we plug in is 80%. It can be modifiable by the instructor.
Okay, so you can put 75, you can put 85. That's great. 90, whatever. So what about, obviously, a lot of us can't get to the classes, and especially here in California. You're in Michigan. I don't know how it is back there, but they've shut us down for another couple months, maybe into the year.
Okay.
We still get certificates based on what they're doing via distance learning on your program.
Absolutely. And then that ties in very nicely with the emulator. We're finding that a lot of the school systems that are in the same circumstance are really attracted to the emulator because they can couple that with our hands-on learning curriculum, and they can call that contact lab time. So I can show you, for example, sorry, I'm monkeying around with, okay, if I go into our emulator, let me just stretch that out. So this is a mathematical model of a machine, and this is a reverse engineered control. And I can program in this, I can load programs in this, I can save programs in this. If I go to memory, you'll see I already have a program loaded in the control. I can operate this as if I were standing at a machine. So there's a whole bunch of exercises and tests that can be used in conjunction with this emulator as if they were standing at the machine. And this can be utilized at their home computers provided they have internet connection. So this would be one of the approaches that you might want to consider for trying to bridge the inability to be with your students for a couple months. Now, this is getting further ahead in the curriculum. If you're starting with a brand new class, you would actually just start them out with the way you'd be probably running your own class. So if we were to look at Total Machinist, it first starts out with core skills. So it starts out safety for machining, bench work, layout, materials, shop math 1 and 2, reading manufacturing blueprints, precision measurements, speeds and feeds. So this is what we call core skills. Then it would lead into manual machining, drill press, manual mill, lathe, precision grinding. And then we start to lead into the CNC milling setup and programming, lathe setup and programming, and then all of the project-based learning I was telling you all about a little bit earlier. And then from there, you can go into Renishaw probing, multi-axis machine setup, and then you have your NIMS practice tests. All of this is available in Total Machinist. So, for example, if they wanted to go into, let's say we go into Shop Math Level 1. So it took me to wherever the student last left off. So they did a post-test under degrees, minutes, seconds. So there's rounding decimals, order of operation, fractions, inch metric. So if we were going to go into order of operations, just to give you an example. Now this pre-test was already taken, so it's not available for me to open up to show you. I can show you the test results. So someone's already gone through this. They've done the comprehensive, they've done the post and the pre. After you do your pre-test, you would then, nope, I'm gonna turn her off. So after they've taken the pre-test, they go through the simple instruction. So for example, let me turn that up. Okay. There's many ways that you could go about solving a problem if you don't understand or know the order of operations. So we pose the problem, we show them multiple solutions, and then we talk about what the correct answer is. And then we start to address what is order of operations. And in this, we use kind of a common anecdote that a lot of machinists are familiar with, which please excuse my dear Aunt Sally. And that basically stands for parentheses, exponents, multiply, divide, add, subtract. So as we start to page through this curriculum, there's instruction, and then there's a lot of examples, teaching by examples. So here would be another example following the rules. Once we've gone through a number of these examples, you can see here there's like 7 of them, we then would start to go into interactive exercises. And in an interactive exercise, we hit start, and you can see the clock starts ticking, and I can get up to 3 strikes. So the dashboard's always the same for any interactives. They don't have to learn this multiple times. So if I go ahead and I click on this, and let's say I say subtract, enter. All right, so I get a strike. Let's say I say divide, enter. And then I say subtract. Okay. I can then advance. I could play another game, or I could play the next game. So in this case, if I did multiply first, I'm going to get it wrong. If I did subtract first, I get it wrong. And if I do add, I get it wrong. But I can go back in and I can make another attempt. So let's try parentheses, multiply, subtract. So what we're doing is we're giving them the opportunity to play in a sandbox and make mistakes and hopefully learn from the redundancy of those mistakes. And if they want to, they can go backwards and forwards. They can go back through the material as much as they want until they feel they've really mastered that material. Once we start moving through core skills, then we really get into more sophisticated curriculum. Is anybody on this call doing anything with manual machining?
We do at Cal Poly.
Cal Poly? You like mill or lathe, any particular one?
We're still using manual lathe.
Manual lathe, okay. So if I click on the manual lathe, we start out with, everything starts out with safety, an overview. Then we get into the fundamentals. Let me open that one up. So we talk about a 3-jaw chuck, independent 4-jaw chuck, tool holders, tooling. I'm just gonna click into like a 4-jaw chuck, and just give you kind of a feel for it. So everything in these are video based.
Is it giving audio? We just can't hear it, Chris?
Yeah, I'm sorry, it's giving an audio. I hear it. Perhaps you're not hearing it through the Zoom.
Yeah, that's just a Zoom thing, I believe.
Yeah, I turned on the closed caption though as well, so you could see a little bit.
Yeah.
If you want to share the audio, when you select share the screen, there's a couple of tick boxes at the bottom
Oh, is there?
that you have to check. Yeah.
Oh, okay.
At least in my version of Zoom, they are there.
Let's see here.
So next time that you're going to share.
Oh, okay. Yeah, I don't want to mess it up now.
Correct.
Thanks, Victor.
Sure.
Yeah, thanks.
Victor.
So, anybody on this call that has an interest in what we're doing, we can work with Frank to make sure we set you all up with your own, version to play around with. So you'll be able to go through all this firsthand. This is unfortunately just a really quick overview just to give you kind of a taste of what we're doing. But so as we go through a lot of this introductory, what happens then is we start to get into the project base, right? So we talk about tool holders, we talk about the tooling, and then we're going to get into project 1. So if we start out with introduction, and I can get into a pretest there, but what we're starting out with, this would be our print for the first project. Then project 1, slide 2, introduction. Here'd be the next one. And then we get into project 2, turning between centers. Okay, and then that would be the next project. And what we do is we walk through step by step each one of the main procedures to complete that part. I'll go back up to to project 1, and I'll show you that pretest. So a lot of times there might be images in there. For the most part, it's true, false, multiple choice. I'll just go ahead and submit that. What this is just a measurement of what you knew coming in. And it's a benchmark you're setting for yourself for your final. So now we're going to walk through this, and we're going to talk about what are we doing: roughing, finishing, shoulder lengths, undercutting, threading, drilling, boring, undercutting, threading. If you want to pull down the print, it's right. It's always available to you. In all of our learning, there's resources. So if you wanted to grab the prints or there's other materials, it's always available in these little libraries. And as we walk through this, he's gonna be setting up to face the part, and then we walk you through it. We kind of accelerate some of the video of doing it. As you can imagine, can be a lot of passes in doing it. So he's gonna face the part. This will just give you an idea of the quality of the video as well. Incidentally, our instructor here is a journeyman machinist. He worked in industry for a decade. He actually was in the Coast Guard before that on a ship. And now he's the department chair and instructor at CITEA. Oh, I'm sorry. It's now CITEA Polytechnique. What's nice about this is that if a student missed a day or they wanted to go through it again, it's always available at their fingertips to go through and review this material as much as they want, right? So as we move along, and you can pick and choose, what you want the students to go through. Then we get into machine setup, we get into milling machine programming. In the milling machine programming, this is where we'll walk through program structure, Cartesian coordinate system, circle interpolation, cutter comp. We'll get into drilling, tapping cycles, different labs. And then once you've accomplished all of that, and actually I can show you like Cartesian coordinate system, programming methods. So we look at absolute worksheet 4. So in this one, here's a new game, and they have to pick the coordinates. So for A, it'd be, if you put a 1 and a 1 and you hit draw, it says an error occurred. The X value must have a decimal point. And that's what you'd want them to know about machining. You need that decimal. And then if we want to go to B, and that's 1, 2, 3, and 1, 2, let's just say we messed that up and we put -2 and 3, and we draw that, it'll literally go to the place where you sent it. So if I flip this around, okay, I'm back in business. And again, I have a clock, and it's a fun little game, but the whole point is to get them engaged in learning about this important part of programming is knowing location. And we cover absolute and incremental. And then as they progress through this, in the resources, if you want to incorporate this in your training, they could do all of this at home with the emulator that I was showing you earlier. They can start to program a box with a GO1 by filling in the blank. Then you get into a GO2, fill in the blank, GO3, and you start progressing through all of this. And then this would be the first test. And it's all building blocks. So now you're getting into circle hole patterns, bolt hole patterns, linear and circle. And then you have pocketing routines. And then your final part would actually be the NIMS level 1, very similar to the NIMS level 1 part. And we do the same thing for the lathe. Then, as you're moving through that, we have all of the project-based learning. So there was the one I was showing you where you flip the part. So here's the print and the overview, and then the setup of the machine, programming the part, and then inspecting the part. So there's machine preparation. You're going to do warm-up, work holding, so we can get into the vise, setting the vise on the table properly, and then I believe this is putting in your jaws, soft jaws. And then I think he's touching off the machine here. So work offsets. We can just kind of. So we do get very in-depth, very detailed, very comprehensive. Again, they can practice these touch-offs with the emulator. We have tools, we have offsets, we have the programming, first operation, face milling. Okay. And then it'll even get into the inspection.
Chris, there's a question real quick from
Sure.
Eric Lee.
Sure, please go ahead.
Came on a little bit late. A lot of our schools have given their students Chromebooks to take home. And so and I know that Chromebooks aren't all created equal. They have different variations, different models, and different, ones that have memory, that have hard drive. His question was, can you run this on a Chromebook?
So you can do all of the learning I've shown you on a Chromebook. The thing that would probably have to be benchmarked on your particular Chromebook is whether or not the emulator can be ran on it. So there are some Chromebooks that have memory that actually can run the emulator, but the majority of them, because of budgetary issues, may not have all of that on board the computer.
So we could definitely send him a code to practice on. We can send it to anybody. As a teacher, you're going to get a free code to kind of evaluate this by being here today. But the only way to try the emulator is to just get a code and download it. But if you can't, I don't know if Eric has a hard drive or memory, but it's definitely worth a try. But everything else works pretty well, right?
Yeah, everything else is 100% supported. And I would encourage you to try to download the license on the emulator. I'm sorry, download the emulator on the Chromebook and see if it works. And you can give us a call too.
He actually,
and we'll walk you through it.
He doesn't even have a Haas, but he has some other Intelitech equipment where they do have some virtual versions of those CNCs. That might be a way to generate the code from here and maybe bring it in there. But they're not going to be able to run that virtual emulator either. So I don't know. I mean, definitely worth a try.
It's worth a try. And if you even want to just diversify and show a different control, the curriculum is detailed enough that it would walk you through step by step.
I don't know if he saw the Haas emulator. Maybe at the end you could maybe show it again.
Sure, no problem.
Thank you.
Okay, no problem. Any other questions while we're pausing? Okay. All right, so that would be, the project-based learning. Then we get into the CAM. So we right now provide 2D lathe and Mill 2D in the most recent, and we're bringing on board Mill 3D training as well. These were written to the MasterCam standards, certification standards, and they also tie in really nicely with our other teaching. So as I mentioned earlier, this is the exact same project that we use for teaching M and G code programming. But now we're showing the connectivity between that programming and automated programming MasterCam, so the students really can see the connectivity there. And in a sense, they're learning how to do it two different ways twice. So you'll see that it walks them through the exact same steps that they would have gone through with M and G code, but it's in the MasterCam way. So if I go into introduction, there's the overview of the geometry. So let's look at geometry. And so the students will use this side by side. So they can go download the MasterCam HLE and use this on their, I'm sorry, you know what, I should, it is playing audio. I apologize if you can't hear it.
We can see the CC.
Yeah, good. But you could go split screen, you could have dual monitors. and then walk them through step by step. With all of these, and then if they want to download the project, so here's the exact project they're doing. And then we also have step-by-step print material that they can print off in a PDF if they want additional material with this. And again, everyone on this call is going to have access to everything, so they can go through this step by step and get a much more in-depth feel. The whole purpose of what we're doing today is just to give you a quick overview of what's available. Let's see here. I'm going to pop out of there. And so we had our core skills. We looked at manual machining. We went into the CNC setup and programming core education. And then we looked at a mill project. And if you're using the Haas control, we also teach the mill intuitive programming. And then we have the lathe setup and programming. And then we get into lathe projects. So I'll just pull up a lathe project just to show you what a sample of that looks like. So this would be like a bushing that fits on another piece. As I mentioned, all of these become an assembly as well. So you could teach individual projects or you could teach it as an assembly. If you want to get additional materials to this project, if there's anything else available, you click on resources. In this case, there is, you could download the actual project here. Pop out of that. So then we have lathe. We get into the Renishaw tool setter and probing. And then we have the how to set up a multi-axis machine with a Haas, and then all of the NIMS practice tests for all of the curriculum that we're providing up in here. And then from a teacher's point of view, what happens is you're set up in your own organization. So if you're K&B Tools, you have your own organization and you'll have your own classes, unique classes. Students will get a unique code, a subscription code. They'll self-enroll and they're automatically deposited into your class. So there's very little administrative work that you need to do. Once they've self-enrolled, you can click on this little pie chart here, which is called the Class Assessment Report. And this will open up and it'll show you your students. And it'll also show you their progress. So this is just a demo class, but I can come in. If I click on this little button here, it'll open up my portfolio skills assessment. And you get a little dashboard so you can see the pre-tests that were taken, the correct answers out of the total questions, the percentage. So on the pre-test, this person was scoring about a 71%. On the post-test, about 94.8. So that's almost a 20% improvement between what they knew and what they know now. The quizzes, and then there's the comprehensive exams, which are kind of running in line with the post-test. And the overall test score average is 91%. And then you can go down each one of these individual tests. And these are the pre, the post-test, the inline quizzes, and the final exams for the portfolio of all of that content that I was showing you earlier. So you can see we were in the Shop Math Level 1, Order of Operations. There was an order operations, and then there was the quiz for it. There's fractions, understanding fractions, multiplication, canceling, division, degrees, second. So all of that is broken down in what we call learning modules, and then each one of those is broken down to the question into learning objectives. And you can see that this goes on and on. It's a very detailed portfolio of everything that they were learning at the time. Okay, so this is where you as an instructor could go anywhere and look up, your students' progress and get back to them too. Okay, there was someone that joined a little bit later. We were going to just pull up the emulator real quick. So just the emulator is a virtual machine with the control. Now this happens to be a Haas control, but as I mentioned earlier, there is very detailed curriculum that walks you through this entire control. So whether it's an IntelliTech or a Haas, it helps you teach the principle of teaching an industrial control. And it operates just like if I were running the actual control machine. So if I select this new program, and then I go to memory, and I hit, I can change out my part, so I can reset my material, and then I can hit cycle start, and I can start machining again. Let me just give you a better view here. You can see I'm actually cutting a brand new geometry.
How about iPads?
iPads, no. No, I'm sorry. The computer has to support something called OpenGL. If it's supporting OpenGL and it has memory on it, it can probably run this.
Great.
Okay,
Well, we're getting close to the end of our 50 minutes. Actually, we're at 150.
Oh, perfect. Well, any other questions, or I can?
I have a question. What about a lot of teachers have created their own lessons and they're in PDF format, or they have videos they've created. Can they supplement this package with some of the stuff they've already created and have it available, like as a drop, like you grab that other
well, what we'd allow them to do as a part of this is they can go build their own course if they want to augment what we have and incorporate their own stuff.
Like a PDF drop-in or a zip or something like you were doing before?
They absolutely could do that. They could upload it directly to their to the course.
No, great. If you guys are interested, we're happy to send you anybody's on this call, on this Zoom presentation, we'll get a free evaluation login, and we can actually get more in detail on this product. But it's been very popular, as you know, because of the circumstances of COVID. But any more questions up until for Mr. Bien? I think we're good, Chris. Thank you so much for your time today. Hopefully we're going to see you tomorrow. Is that correct?
No, I think Wednesday.
Okay, Wednesday it is.
Yep.
Are we going to be doing the same thing or anything different? Pretty much the same thing, right?
Same thing on Wednesday, correct.
Okay. Appreciate you. Any more questions before he hangs up? We have a minute or so. Like I said, email myself, frank@paytongroup.com, or chris@paytongroup.com, and we'll send you a free login for an instructor use.
Yep. We'll actually set up an organization, everything for them, Frank, so that if something they want to incorporate, they'll be ready to go immediately.
Okay. You heard it from Chris. Thank you, Chris.
Okay. Thanks for having me.
Thanks, Chris.
Hi, Chris.
Good stuff.
Oh, thank you. Have a great day.
All right. You too, bud. Thank you. Take care.
Okay. All right. Bye.